So today we're talking about, well, Rocket a bit, but mostly I want to talk about code generation, which is obviously, well, if you know about Rocket, it's obviously what sort of makes Rocket Rocket. And I think code generation is a somewhat underappreciated and sometimes way overappreciated feature of Rust. But I think if you use it well, you get really nice APIs that actually help you write better code or help you write better software. And I like to think Rocket is an instantiation of that. I.e., if we can use code generation well, then we can get good applications, good software. So the way I want to structure this talk is sort of in three stages. First, I want to introduce you to Rocket. If you don't know about Rocket, it's what I think is a simple, fast, and type-safe web framework for Rust. And I'll say a bit about what I mean by simple and type-safe. Fast is self-descriptive. And it's powered by Rust code generation. Without Rust code generation, we wouldn't have Rocket. And the idea is that Rocket lets you write secure and robust web applications in a way that nothing else really lets you do. The closest that other web frameworks get are those in languages like Haskell, using something like typed Haskell or something like, what's it called? Whatever. Templates, yes, template Haskell, thank you, that's the right word, template Haskell. Great. Then I want to talk about code generation, so after you get to know a little bit about how Rocket looks, how Rocket code looks, and what Rocket does, I want to talk about code generation in Rocket and in Rust. So when Rocket was launched, there was this pervasive comment about how Rocket was so magical, how Rocket was like Rails and its magic, and like avoid it like the plague because it's too much magic. And I want to demystify that. I think code generation isn't magic. I think monkey patching and Ruby mixins are magic, but not code generation. And in doing so, I want to show you very briefly what the code generation APIs look like. And when I say that, I mean the procedural macro APIs, which are very similar to what you can do now with Derive, if you've used that. And then I want to talk about a bit about the future. So what's coming in future versions of Rocket, and how Rocket will continue to use code generation to give you a nice interface and really strong promises. So that's sort of the path we're taking for the talk today. Quick introduction on Rocket. Spend about 10, 15 minutes on that. If you already know Rocket, feel free to doze off for 15 minutes. Then we'll talk about code generation in Rocket, let you know how Rocket uses code generation, what Rocket actually does, what code it generates, and how that works. And we'll talk a bit about the future of Rocket. OK, so let's start with an introduction to Rocket. So again, Rocket is a web framework for Rust that ideally makes it simple, i.e., like it's very easy to read, very easy to write fast web applications, what you would expect from a program written in Rust, without sacrificing flexibility, so you can do what you want to do, not what the framework wants you to do, or type safety. And I've underlined all of these things, but I really want to underline type safety. It's interesting that if you write a program in Rust, it doesn't mean your program actually takes advantage of type safety. I.e., you can dynamically cast in Rust if you're not aware. And that's like a really nice escape hatch if you're coming from the web, because the web is the string, and you're trying to take the string and make sense of it in Rust. But if that's what we do, if we really do just dynamically cast things, then we're not really using the power of Rust, the power of the static, strict, strong type system that Rust gives us. And Rocket aims to exploit that type system. So that's what I mean by type safe there. So how did we get to Rocket? So this is the timeline. And every time I do a talk in Rocket, this timeline gets wider, which is nice. So Rocket launched about 8 months ago or so. And shortly thereafter, there was a version 0.2, brought a bunch of nice stuff to Rocket. And about 5 months after that, there was a release of version 0.3, so just last month. And now we're at the end there. It's gained awesome traction. There are at least thousands of users and a couple dozen companies using it, which is pretty awesome. Something that's not on this timeline that totally surprised me was this blip here, was how quickly someone told me, hey, I just launched something in production and my company's now using Rocket. It was like 2 weeks after Rocket launched, I got an IRC message saying, I rewrote this thing in Rocket, thanks so much, I can throw away Node. I was like, all right, cool. That's great. Thanks for using version 0.1. I appreciate that. So that was quick. Now when I get those kinds of messages, I'm more excited than scared or nervous, I think. But it was surprising how quickly that happened. Just as a bit of fanfare here, when Rocket launched, it got really nice coverage. Hacker News loves Rust, sometimes. But they generally liked Rocket, so much so that Rocket was the top trending project when it launched, which I thought was awesome. So I got over 1,000 stars in the first day on GitHub, so that was fantastic. OK, so this is the timeline. Now, obviously, I'm missing a big component of this timeline, which is what happened before the launch. And, well, obviously, I worked on it. That's what happened before the launch. So I'd been working on Rocket for quite some time, about 8, 9 months before Rocket actually launched. And mostly a full-time effort. Kind of have to step back from Rust for a few months in the middle, but mostly a full-time effort. And I just want to give a very tiny blurb about why Rocket exists. It wasn't just to create a new web framework, because there are so many of those in so many different languages. It's like, stop, no more web frameworks. I believe that, so why did I make Rocket? Well, I've been working on the web for a very long time. I've been writing web applications for a very long time. And I've been writing Rust for less time, obviously, because it hasn't existed that long, but almost 5 years now, like 4 years, so way before 1.0. And at some point, I wanted to marry the two ideas. I was like, yeah, let me write a web application in Rust. Let's see how this works. And I tried doing it, and it was not fun. When I program, I like to have fun. Otherwise, I just stop programming. And it was not fun, and it was not taking advantage of the type system. And for those two reasons, Rocket came into existence. It was really an idea of how do we actually make this super easy, even though Rust type system is not always the easiest thing to use, and at the same time, how do we take advantage of that type system, even though we're going to make it easy to do this? OK, so Rocket, web framework for Rust, makes it simple to write fast web applications without sacrificing flexibility or type safety. Great. So let's take a look at what a Rocket application looks like. This is hello world. It's 4 lines. This is really all you write. Well, caveat, you need a main function. And yeah, so this is what you write. And first of all, I just think it's so cool that you can write this, and this is Rust. Like this is like a C successor, and you're writing this. I just think it's awesome. So what is this? What are you looking at? Well, the first thing up top here is an attribute. If obviously you guys are familiar with Rust. So it's an attribute. And in Rocket, we call it the route attribute. And it's a description of matching conditions. It tells Rocket, these things have to be true for a web request to be routed to this route. For Rocket to give a web request to this route, these conditions have to be true. So in this case, you need an HTTP request with the get method to the route path. The thing at the bottom is the route handler. It's just a function. It's not a special function. It's just a function. And it will be called if the route matches, and Rocket will call it, and it'll produce a response, which is an arbitrary type. Choose the type. As long as it implements a certain type class, you can return it. And that's it. That's really what makes up Rocket applications, are these routes. And if you were to actually run this thing, and you were to go to the route path, well, you'd see hello world, as you would expect. That's really all it takes to write a hello world application in Rocket. Now, like I said, you do need a main function. So this is not the 100% complete application. And the main function looks like this. So this is the main function. And there are a couple things that are happening here. The first thing you see is this Rocket Ignite. So obviously, you need to turn on the rocket if you're going to launch this thing. So you ignite the rocket. And then you need to put some stuff on the rocket. In this case, we need to put routes on the rocket, because those belong in space, apparently. So you mount some stuff on the rocket. And what mounting means is you just namespace the route. So for instance, here, we're not really namespacing anything, because we're just saying mount it to the route path. But if I were to change that to /hello, for instance, then every route in sort of the list of routes would have to be prepended with /hello in order for Rocket to route things to it. And then finally, you launch the rocket, and that starts up the server. And it also prints a bunch of emojis. which is a contentious point. It was like the second GitHub issue after Rocket launched. Emojis, stop, please, I don't want that. But that looks like this. You get 3 emojis, not so bad. When you launch it, you get this thing. Rocket tries to be very, very helpful while you're developing your application. It tells you everything it knows about the environment, where it's actually serving this thing, the configuration of your application. It tells you what routes it knows about. And finally, it tells you where your application is actually being served. And, emojis. No more emojis after this, just 3 emojis, but still a lot of backlash. So be careful if you choose to put emojis in your applications. You also can't get rid of them, which is great. You can try. They'll come back. All right. Mounting and launching. Great, so that's what our full application looks like. Pretty simple. This is really all you write. Obviously, you need to extra and create Rocket and things of that nature, but this is really the entire application. All right, so this is fine, right? This is cool. We can write a hello world, but we can't really do anything particularly interesting yet from what I've shown you. We can change the path, so we can change get slash to, for instance, get slash world. And now we'd have to go to localhost 8000 slash world. We change it to slash Sergio, and then we'd have to go to localhost 8000 slash Sergio. But ideally, we can do more. And of course, you can do more. And so I want to talk to you about dynamic paths. So dynamic paths, as the name implies, allows you to have path segments that are dynamic, i.e. the user tells you what the value for that path segment is. And so here is our reworked hello world example. And you can see that we have parameters in brackets in the route attribute. So we have name in brackets, and that makes something dynamic. So whatever the user types into the path at that segment will be the value that the name parameter gets. And so again, these are in brackets. That's how you tell Rocket, hey, this is dynamic. I don't mean the literal slash name. I mean the dynamic name. And you can do more than these. You can do more than that. You can do slash name slash age, for instance. And now you have 2 dynamic parameters. And the names of the parameters have to match the names of the function parameters. If not, you'll get a very nice compile time error that tells you, hey, these don't match. Look here, not the same. Please figure it out, what's going on. And any type that implements this trait called from param is allowed. So string implements from param, that Rocket implements from param in its library for you. U8 also implements from param, and so you can use these things. And the semantics of this are that Rocket will call from param for every parameter you list, and if the conversion succeeds, i.e. if from param says, yep, this is a valid parameter of this type, then it'll call your handler. Otherwise, it can't call your handler. And so it does it. So the implication of this seems rather simple, but the implication of this is actually deeper. For instance, if we want to get a path from a user, i.e. we're going to have a static file server, so we want a full path. One very common attack when people try to write static file servers is to allow any file to be read, as opposed to just the files in one particular directory. And there's been a bunch of people on Reddit/Rust. They're like, look, I wrote a static file server in Hyper. And the first comment is like, oh, I can read your passwords. Great. And so even here, even something as simple as for parameters, Rocket protects you here. So for instance, this is how you write a file server in Rocket, and it's totally safe. And so what's happening here is we've added these dots. I'm not going to explain them, but all it says is that you're matching not only this segment, but every segment thereafter. And we're capturing that in a path parameter, which is a path buff. And the from param implementation for path buff will actually verify the path and ensure that you are not, you cannot have a directory traversal attack. And so this is exactly this is in fact what we put in the guide about how you write a static file server in Rocket. And it's safe, and you're protected. All right. So the last thing I want to talk about before we talk about how this is actually working is what I believe the most exciting part about Rocket, and that's this concept of request guards. So for what we've seen so far, Rocket helps you with input validation, but there's there's more to it than just the path. There's arbitrary data in the request, and you want to make sure that this request contains some information. For instance, I want to check that it identifies an admin user. Well, there's nothing to match in the path for that. There's really nothing. It's just arbitrary what an admin user is. Maybe it means looking at a cookie. Maybe it means looking at a header. Who knows? So Rocket's mechanism to be able to describe these kinds of validations are request guards. So in a route, you can list any number of parameters in the handler that implement the trait from request. So here we have one, and it's admin user. So we have some type admin user. And what the admin user type does is it implements this from request trait, and the trait will verify that the request actually contains an admin user, and it'll convert whatever it needs to give you a type that says, yep, there's an admin user here. And if it can't do that, well, it has one of two options. It can either fail, which says, no, do not call any handler that needs an admin user, or it can forward, which says, OK, look, this route, don't call it. It's not an admin user, but maybe someone else can validate the request. Maybe try a different kind of user, or whatever. Just try something else, Rocket. And when you forward something, Rocket will try the next route that the nomenclature, whatever we say, is to collide. So for example, here we have two routes, and they are both requests. They're both match the admin route, the admin path for GET requests. So these collide. And if you were to actually run this, Rocket would say, hey, these collide. But we can fix that collision by ranking these routes. So we can add this rank equals 2 to our routes. And that means, hey, when there's a collision, try the thing with the lowest rank, and then try the thing with the next highest rank, and so on and so forth. And like I said, if you do this wrong, Rocket will give you, and ideally, a very helpful error. Here it is that says, Rocket failed to launch because there are collisions. These two things collide. Please fix them. Oh, by the way, did you know about ranking? That sometimes fixes this. OK, so you have this. So what's going to happen here? Well, if you were to go to get/admin, then Rocket will try the lowest ranked route first. So that's the one with the admin user, which means you need an admin user to be validated, to be authenticated by the request. And then if that fails, Rocket will try the next ranked route, which is the one below that, which says you just need a regular user. And so what we've done here is actually implemented both authentication and authorization. So we've actually encoded our policy with routes, request guards, and forwarding mechanism. And we can go further and keep ranking things. So for instance, if you want to have a route that has no requirements, maybe to tell the user, hey, log in so I can figure out if you're actually an admin user or a regular user, then we can do that. So I think this is the most exciting part about Rocket, is the ability to really encode arbitrary policies, whether it be authentication, authorization, or whatever. Request guards and forwarding allow you to do that. OK. So that's really all I want to say about Rocket. There is a lot more. I mean, you can do pretty much whatever you want. So there's a lot that I'm not going over. I'll link you to Rocket's website, which has a guide. It's pretty extensive. The documentation is fairly extensive, and it talks about much, much more that I just don't have time to cover. OK, so next up is code generation in Rocket and Rust. So let's go back to our Hello World example. Here it is. We have our route, our high route for the root path, and then we have our main function. Now, I've restyled it a bit because I need to fit code in this slide. So what code does Rocket generate when you write this program? Well, it generates this code. Great, yay. What is this? Well, let's walk through it. So the first thing that happens is Rocket takes your route attribute and the signature of the function and generates this route info structure. And really, you can sort of just map it directly. You can see exactly how the mapping works. It takes the name, makes it a string, takes the method, makes it an actual method type, takes the path, puts it in a string. This handler we'll talk about in a second, and format and rank are other aspects of Rocket that we don't have time to talk about. The next thing it does is it generates this function at the bottom here. So that's this high route. That's what that handler is. And what this is, it's a monomorphization of every route. So it is taking any possible signature that you can write and converting it into one signature, because at the end of the day, we are statically typed. We can't take a bunch of different signatures without doing dynamic dispatch, so we create one signature that effectively does dynamic dispatch at compile time. And all it does is it'll call that function, so what you actually wrote, it'll get that response, and it'll generate an outcome from that response. And the outcome is just what happens when you actually try to write that out on the network. And finally, to tie things back together, we have that routes bang macro in the mount. And all we do here is we construct a route from the static information that we generated. So that routes bang becomes a vec, and the vector contains all the routes that you wrote in the routes. And Rocket will do all the name matching necessary to actually make that happen. So that is the code that Rocket generates. Actually, pretty straightforward. And the most interesting, or the key here, is this monomorphized function here. It's that we can take any signature and convert it into a function that has a static type, that has one type. OK, so this is a pretty simple example, but what about when we have guards and parameters? What code gets generated here? Well, the code for the route info is pretty much the same. We just kind of read everything, parse everything, convert that into a route info structure. And then Rocket has all this information to be able to convert it into something that we can use at runtime for routing. But the code for the guard and the parameters is more involved. And I could not fit the code that Rocket generates. So I took the code that Rocket generates and rewrote it into what you might actually write by hand. But even that won't type check. So I've actually had to fuzz the types to fit this into one slide. But note that it is pure to what Rocket is actually generating. So what code does Rocket generate? Well, we're going to move this function up here so we have room for the code. And this is what Rocket generates. Again, it's a function that goes from request to outcome, just as before. It's always going to be that. And what it does inside is sort of what you'd expect. So for every parameter, it generates a little bit of code. So for instance, for this user parameter, it generates the code that calls from request for a user. And it checks the outcome of that call, and it does what you might expect. If it's successful, it gives you that value. If it's a forward, it just forwards the entire request. And if it's a failure, it fails with that status code. Well, what does it do for ID? Something very, very similar. It calls the from param implementation. And if that succeeds, then you get a value. And if that does not succeed, then you forward the request that says, hey, try something else. And this really is the code that Rocket will generate, modulo making it very pretty to fit in this slide. All right. So in summary, this is all the code generation that Rocket does. It takes that route attribute and generates a route info structure, a static route information structure. It takes your route handler and it monomorphizes it into something that goes from request to outcome. And then it takes your routes bang and converts it into a vector that containing routes that match your static route information. That's it. If you tell me this is magic, then I don't know what magic is. This is super simple. If you just sat and thought about it, this is probably what you do. This is not something super complicated. You can cargo expand. Before you compile, you can do rocket code gen debug equals 1, and it'll show you exactly the code that Rocket is emitting. And there's no magic. It's just doing things that you would do otherwise in your handler for you, so you don't have to, so you don't get it wrong, so you do the right thing every single time. OK, how does this work? How does Rocket make this code generation happen? So let's talk a bit about the internals. So the procedural macro API is actually pretty simple. Rust will call you, and it will give you the syntax that, say, the attribute was applied to, or the syntax inside of a macro call. And then your job is to take that syntax and emit other syntax that it should replace whatever syntax was called with. So you take some syntax, return some syntax, that's it. Really rather simple. The types of this syntax thing, and I've simplified it, but this is effectively what's going on. Syntax is really just a vector of these token tree things, and a token tree contains a node. So like, for instance, a semicolon, or a plus, or a string literal, or something like that. And a span, which says, here is where in the code this token occurred. And the span is useful for error reporting and things of that nature. The span is not something that you can actually get with derive, for instance. So if you were to do derive, the span information is just gone. You panic, and you can't tell the user why you're panicking. Just try to explain what's going on. But spans are extremely important, and they will be in the Proc Macros 2.0 API. So this is sort of what it looks like now and what it will look like in the future, except much, 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 much simpler. So this is the future. The present is muddy. The future is much nicer. All right. So that is code generation in Rocket and Rust. So what's next? What's coming up? Well, we're going to keep using code generation, as you might imagine. And we're going to do typed URIs. For the next release of Rocket, I really want to have typed URIs. And the idea is if you have a route like this that takes in a parameter of ID, that you can then create a URL to that route using the actual types that you'd expect. So for instance, I can call URL bang for the retrieve route and specify that the ID is a paste ID of 100. Or we'll actually call into for you automatically, so you can just give anything that implements into for your type. In this case, assume usize or whatever, U32, implemented into for paste ID. Then we could just write the thing at the bottom. And the nice thing, of course, is that if you get this wrong, you'll get an error that says, nope, those are not the right types. So you might imagine changing your URLs, and then everywhere you try to generate a URL for that new route, it'll fail compile time, which is a really nice property to have. In this case, we'll just get /100. So it's just replacing that ID with whatever you pass in and getting /100. Pretty straightforward. The next thing we're going to do is database support. So to use databases with Rocket now, it's a bit cumbersome. This is what you write if you were to do it. This is what you would have to write. You can do it, but it's not super elegant. It's going to get much, much simpler. So what I want this to look like in version 0.4 is like this. So in your rocket.toml file, you're going to specify, I have a database named MyDB, and the adapter is Diesel's SQLite. And then in your actual Rocket file, in your code, you would just derive some trait and tell Rocket, oh, the database that I want to access with this type is MyDB. And then you can just use that type as a request guard in your code. And so it really is taking something very big to something very small to make things really nice and easy to use. Again, we really want to get rid of this boilerplate, but we still want to keep type safety. So that's all I have to say about what's coming next. So at this point, you've heard all about Rocket. You have some idea about how code generation works in Rocket. And I could end the talk here, but I thought I'd have some fun at the end of this and try to dispel some myths about Rocket. It's very interesting what happens when you release something and then you let other people tell you about the thing you just released. And I feel like the web is, anything that has to do with the web is particularly sensitive to this topic. People have very strong opinions about the web, and then we get JavaScript. So I don't know how this works. So the most, this is an opinion. It's not really a myth, but I think it's a myth, and that there's way too much magic in Rocket. I don't know what's going on. Hopefully now you're convinced that that's just not true. What Rocket is doing with code generation is simple. It's what you would write, except it's writing it for you. So why do something the computer can do for you when you're going to do the same thing over and over and over again? So hopefully those of you who thought that there was too much magic, you're now convinced that there is in fact not too much magic. There's just code generation. The next sort of myth is that Rocket is somehow unstable. And if you've used Rocket, you might think, well, of course Rocket is unstable. It's using nightly. And if you look at the list of features that Rocket uses, there's a lot of them. Rocket uses a lot of nightly features. Well, I'm here to tell you that that's true, but Rocket is not unstable. Rocket is stable in the Semver sense. If you use Rocket 0.3, Rocket 0.3.1 will not break your application. I'm not sure why people started saying this, but just because Rocket uses nightly doesn't mean that your Rocket application itself is unstable. It means that we have to keep track of nightly. We have to keep track of nightly, and we do keep track of nightly. At most, in the history of Rocket, there have been 24 hours between a new nightly breaking something in Rocket and a new release of Rocket fixing itself for that nightly. So at worst, If you like update your Rust installation every single day, you wait 24 hours and there's a brand new release of Rocket that works on the latest nightly. Or you can just stick on the latest nightly and it'll just keep working. So Rocket applications are not unstable. And finally, on the topic of nightly, is that Rocket is forever on nightly. I should not try using Rocket because my company, we use stable software. Every day, that's all we use in our company, stable software. We don't use NPM 5.0, we use NPM 4.0 because that's stable, I think. No, I know, but, well, we can talk about that one later. All right. So, if I want to use Rocket, then I'm committing to nightly, and nightly does make things like deploying more difficult and things of that nature. So is Rocket forever on nightly? Will Rocket ever work on stable? Well, yes, of course Rocket will eventually work on stable. Every single feature that Rocket uses is being worked on right now for stabilization. Every single one of them. Some of them are actually not needed. It's just because we're using unstable stuff, we actually need to use more unstable stuff. But everything that Rocket is using is being worked on right now. The procedural macros are being worked on right now. Everything that Rocket uses, specialization, everything that Rocket uses is being worked on right now. When is it going to happen? I don't know. That depends on these guys over here. Some things are hard. Like specialization is hard. It's not an easy problem. So it will happen. Maybe this 2019 Rust thing. Maybe that'll get it. I'm hopeful it'll happen much sooner than that, like within a year. It seems like there's enough progress to get there, but we'll see where that goes. But it is not forever and nightly. It will work on stable, and I'm committed to having it work on stable as soon as possible, including writing code in Rust. To make Rocket happen, I had to write a bunch of code in the Rust compiler, and I'm committed to do that again to make it work on stable as soon as possible. So that's Rocket. That's all I have to say about Rocket and code generation. Take a look at code generation. If you're trying to do something the computer can do for you in a really nice way, take a look at code generation. The APIs will get much better. They're already better in nightly. And I think code generation can really improve the simplicity of APIs and the robustness of applications using libraries that use code generation. Here's the website. There's a guide. There's a really long guide. There are tutorials. There's a bunch of Rust docs. There's news. And there's a link to the GitHub repository. I'm Sergio. Here's my email. And thank you for your time.